Alright, so today we're going to be talking about graphing square roots and cube roots. So graphing our roots, basically. So the thing you guys probably need to remember before we start this is all those function transformations we learned last year. And I'm just going to kind of show you guys what that is. So let's say a function transformation would be like if I had f of, well, let's do this one too. So let's say I have a times f of x plus h plus k. Okay? So this number in front that multiplies is going to either stretch or compress your graph. So this is a stretch. If I knew how to spell. Stretch. Language arts degree, isn't helping. Okay. And then the number inside is a horizontal shift. So horizontal shift. So shift means you're just moving your line left to right. Stretch means you're making your line more steep or shallower, right? So it's either going to get steeper or shallower with the stretch. Horizontal is just moving it left to right. And then this K here afterwards is just going to move it up or down. So this is a vertical shift. Okay, and there's two other things that can happen. If this A was a negative, that would flip over the x-axis. So it is a vertical mirror. And if this x was a negative, it would flip over the y-axis. Okay? Now I know that's a lot. But really, the two key things here that we're going to focus on this unit is just the H and the K. Okay? This stuff all just kind of, you'll notice as you do it. But if you can recognize what the H does and the K does, it'll make graphing everything a lot easier. Okay? So to start off, to graph a square root. One of the things, what we're going to use to graph these is we're just going to make a table and plot some points. Okay? But one thing you have to recognize is with square roots, there are going to be half your numbers that don't work, right? Because if you try to square root a negative in your calculator, what does it tell you? It tells you it's not going to work. It's an error, right? So what we have to do is we have to pick numbers that are going to work. So I'm going to think of some numbers, and these are just like 8 by 8 graphs, right? So I'm going to pick some numbers that will actually fit in my graph that have a square root. So I know 0 has a square root, right? 0 times 0 is 0. So its square root would just be 0. So if I plug 0 in there, I would just get 0. I know 1 has a square root, right? Because 1 times 1 is 1, so the square root of 1 would also be 1. I know 4 has a square root, because 2 times 2 is 4, so its root would be 2. Okay, and I think that's all I have that's going to fit. So when I plot these points, it would just be 0, 0, 1, 1, and 4, 2. And this is what the parent function of a square root problem would look like. If you think of it, it's kind of like a sideways parabola, or that U shape, right? But just one of the sides. And it keeps going up forever, just a little bit shallower than a exponential, right? Exponential shoots up, square roots slowly go up. Okay? Now, let's look at an example. So, let's say I'm over here at this problem. Now, there's two ways you can do this, and I'm going to show you, I guess, both ways here. So one way you could do it would be, if you understand what this shift is, minusing 1, and again, with the horizontal shift, it's the opposite directions, right? So if it's minus, it's to the right, and if it's plus, it's to the left, right? The K, plus is up, minus is down, just like normal. But with the horizontal, it's backwards from what it normally would be, because again, basically what's happening is if you are subtracting from the X, you're delaying when those Y values are going to happen to later, okay? If you're adding to the X, you're going to push all those Y values to happen earlier, which is why it's backwards with the X's, because you're basically shifting where the Y values would happen on, because you're adding to your X or subtracting to your X. Okay, so if we understand that this is going to go to the right one spot, what I can do is I can pretty much take all of these values and again just plug them all in, but just basically add 1 to each X because I'm just going to the right one. So if I did that, I'm going to know that this origin is now going to be at 1, 0. It's going to be 2, 1, and it's going to be 5. So 1, 2, 3, 4, 5, and 2. So basically just shifted that line over to the right one. Now the next thing you can do is just do the table like normal. But this time you got to think, well, if I plug in 0, what's 0 minus 1? Negative 1. Does that work? No. So I'm going to have to go up 1 so that I can get 0. So if I go up 1, I get 0. Okay? 1 minus 1 is 0. Square root of 0 is 0. And then to get to 1, I would have to go up 1 again. So it would be 2. 2 minus 1 is 1. Square root of 1 is 1. And then to get to 4, I'd have to go up another 1. So it would be 5. 5 minus 1 is 4. Square root of 4 is 2. See, that's why we went over 1, because we had to in order to account for that minus 1. Okay, to get these same values so that I could actually square root. Let's look at another example. So let's look over here at this one. So square root of x plus 3. So this time it's a vertical shift, right? Up 3. Now I can do the same thing. If I understand that it's a vertical shift, I can go back to my original graph here and still use all these x values, but then the y values, I'm just going to add 3 to each of those because it just moved up 3. So again, I can go to 0 and now 3, or 1 and 4, and 4 and 6. And that's going to be my new graph here. Okay? Now, again, that's the same thing. I went too far up, though. I'm not very good at counting. It would look more like that. Okay. That's pretty much the same thing as this line right here, just up 3 spots. The second line, not this first one. But again, if I don't want to remember those transformations, I can just plot the table. I just have the x in there, so all I have to worry about is what can square root, what numbers I can plug in that square root. So 0, 1, 4 all work, right? Now when I do that, square root of 0 is 0. 0 plus 3 is 3, which is why I started at 0, 3. Square root of 1 is 1. 1 plus 3 is 4, which is why I went to 1, 4. And then the square root of 4 is 2. 2 plus 3 is 5, not 6. That was my problem. Okay. And that is how you do square roots. Let's try looking at this one. This one has a negative in front, right? So let's try just with the table, and let's see what happens. Now, the question is whether this would flip it over the x or the y. We're going to figure that out by making our table. Okay, so 0, 1, and 4. So when we plug this in, square root of 0 is 0. 0 times a negative is still 0. 0 plus 2 is 2. Okay, but when I do the square root of 1, square root of 1 is 1, and then I get a negative 1. Negative 1 plus 2 is 1. Okay, and then the square root of 4 is 2. Negative 2 plus 2 would be 0. So let's see what our line looks like. So I have it going, it's starting up because of the vertical shift. It moved up 2 spots. Okay, but then at 1, 1, it's kind of where it is normally, right? 1, 1. But it's kind of moved down this time, right? And then 4, 0 would be right there. If we were to graph this line, it would look something like this. Okay? So this negative right here is technically flipping it over the x-axis. Okay? The negative is in front of the square root. It's like having a negative in front of your y value, right? It's flipping it over the x-axis. In order to flip over the y-axis, it would have to be a negative x in the parenthesis. So, depending on where that negative goes, it flips over one or the other axes. Okay? Let's look at a cube root. So, cube roots, can we have negatives with cube roots? Well, let's think about that. Negative, let's do negative 1. If I have negative 1, and I times negative 1 by itself 3 times. Negative 1 times negative 1 would be positive 1, times negative 1 would be negative 1. That works, right? I can have a negative cube root, which means our graphs are going to look slightly different, and I don't have to worry about whether or not it's negative or not. These are going to have a domain of negative infinity to infinity because it'll actually include all real numbers. I'm not going to have any imaginary numbers with cube roots. That's only with square roots. So, or even roots, because even roots can have imaginary as well. Let's look at this. So I want numbers that will be nice with cubes, right? So 0 and 1 still work with cube roots, just like they do with square roots, but 4 doesn't have a cube root, right? Neither does 5, neither does 6, neither does 7, but 8. 8 has a cube root, right? 2 times 2 times 2 is 8. So I'm going to be using 8 as one of my magic numbers here, but I'm actually going to use 6 numbers this time because I can have negative 8 and I can have negative 1. Actually, I'm not going to use 6. I'm going to use 5. And 0, 1, and positive 8. Okay. Now, when I cube root negative 8, I'm going to get a negative 2. When I cube root negative 1, I'm going to get a negative 1. When I cube root 0, I'm going to get 0. When I cube root 1, I'm going to get 1. And when I cube root 8, I'm going to get positive 2. So when I graph these at negative 8, so 1, 2, 3, 4, 5, 6, 7, 8. Oh, this actually goes to 9. I could have done 9s. Oh well. And down 2 would be the first point, and then negative 1, 0, 0, 1, 1, and then 8 and 2. So if I connect these points, my pen will cooperate. It looks something like that. Okay, so again, it's kind of like, if I just look at half of it, it's kind of like a square root function, right? But this time it goes in both directions, but on the other side, it's like going upside down. Okay, just kind of flips over the x-axis on the other side and does kind of the same thing. But this cube roots have a domain and range of negative infinity to infinity. They go in both directions forever. Okay, and that is what a cube root would look like. And then again, you would pretty much treat it just like we were doing with those other, with the square roots. So for example, if I did a minus 3, I could shift all those values, I could shift all those values to the right, 3 spots, and then just plot them again, right? It'd be like adding 3 to each of those x values. Or I could shift them all down 3 spots. It'd be like subtracting 3 from each of the y values. Okay? Let's do that. Let's do one more, and again, I'm just going to do a table, just kind of show you guys. First, I showed you the other way on the other one. So -8, -1, 0, 1, and 8. Okay? Plug those in. Square root of -8 is -2. -2 minus 3 is -5. Square root of -1 is -1. Minus 3 is -4. 0 minus 3 would be -3. 1 minus 3 would be -2. And then 2 minus 3 would be -1. Okay? So then I plot these points. 8, down 5, 1, 2, 3, 4, 5. -1 and -4. So 1, 2, 3, 4. 0, -3. 1, -2. And 8, -1. My cube root shifted down 3 spots. Looks something like that. And that is how you graph roots. It's very exciting.